Hello, my dear students. This is Raman Rana here, mathematics teacher, Cambridge International School, Dasua. Today, we will discuss about polygons, interior angle property of a polygon, exterior angle property, and the various types of polygons, and in detail, the smallest polygon, that is triangle. Today we will discuss about polygons. A closed figure formed by line segments. Triangle is the smallest polygon with 3 sides. Quadrilateral with the 4 sides. Pentagon, 5 sides. Hexagon, heptagon, so on. We will discuss in detail the angle sum property, the sum of interior angles and exterior angles. So polygon. Poly means many. Guns means side. Poly, many. Guns means side. A closed figure formed by the line segments. So triangle. Triangle, a line segment AB, BC and AC is the smallest polygon with 3 sides. Triangle. Triangle. Tri means 3 angles. Here triangle ABC, we have 3 sides, AB, BC and AC. So triangle is the smallest polygon with 3 sides. The angle sum property, the sum of all the 3 angles, interior angles of a triangle is 180 degree. Now a 4-side polygon, if sides are 4, that polygon is called quadrilateral. In a quadrilateral, we have 4 sides, A, B, C, D. Always AC and BD are always the diagonals. Same, if we have 5 sides, a 5 sides polygon, that is called pentagon. E, F, G, H and let it is A. So interior angle sum, here it is always 180 degree. 4 sides 360, 5 sides 540 degree. So one formula, if we have a polygon with 10 sides, to find the interior angle property, formula is n minus 2 into 180 degree. For a triangle, number of sides is 3. So 3 minus 2 into 180 is 180 degree. When n is 1, n is 3. 3 minus 2 is 1. For quadrilateral, 4 minus 2. So 2 into 180, 360. For a pentagon, when we have 5 sides, so 5 minus 2, 3. So 3 into 180 is 540. So similarly, when we have a polygon which is having 6 sides, so 6 minus 2, 4. So we will find the interior angles of the polygon, sum of all interior angles. So here 720. So here n denotes the number of the sides of the polygon. So if we have heptagon, 7 sides, so 7 minus 2, 5. 5 into 180 is equal to 900. Means if we have a polygon which is having 7 sides, means angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7. The sum of all 7 angles is always 900. So on. If we have 10 sides, a polygon with 10 sides, so we will apply here 10 minus 2, 8, 8 into 180. If we have 15 sides, we have 20. So we can just substitute the value of n and we can find the sum of the interior angles of a polygon. Suppose we have 12 sides. A polygon is having 12 sides, and we want to find the sum of all its interior angles. So we will take n12. n12 minus 2 is 10. So sum of the interior angles is 1800. Now dear students, what about the exterior angle property? Here, if I am increasing these sides BC, CA, and so this angle A plus B plus C, these A, B, C are the exterior angle of this polygon or triangle. Similarly here, if I am producing this one here, this angle is let X, this angle is Y, this angle is Z, let this angle is W. Sum of all these exterior angle X plus Y, Z, W. For all polygons, the important rule, the sum of all exterior angle is always 360. If we have n number of sides, then the sum of exterior, these angles, this sum is your interior angles. Now I am talking about exterior angle. For exterior angle, the sum is always 360 degree. So here, if we know for an equilateral triangle, if we have a regular polygon, when all the sides of polygons are equal. When a triangle is regular, means it is an equilateral triangle. In that case, all angles are then 60, 60, 60. So this angle is supposed to be 120, linear pair, 120, 120, 120. And in other polygons also, we can apply this concept of linear pair of angles. If we know X, we can find this angle is always 180 minus X. Like here, this angle is always 180 minus A. This angle is 180 minus B, and this angle is 180 minus C. So always for any polygon, the sum of exterior angles, here these are the exterior angles, angle 1, this is angle 2, angle 3, angle 4, and angle 5. So sum of all these angles, angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 is always 360 degree. We can do it with the help of activity. We can draw one polygon, quadrilateral, pentagon, hexagon, and we can cut these angles and we can paste. After making these angles, we will find angle 1, angle 2, angle 3, angle 4, 1, 2, 3, 4, 5 and 6. We'll find the sum of all the angles. Exterior angle of polygon is always 360 degree. If we have n number of sides, then the sum of interior angles we can find with the formula n minus 2 into 180 degree. The exterior angles, sum of exterior angles. If we have a polygon of 30 sides, the sum of all interior angle is 30 minus 2, that is 28, 28 into 180 degree. Now if a polygon is a regular polygon, then all angles are of same measure. They are always of equal degree. So how to find? We know, suppose pentagon, if we have a pentagon, regular pentagon means 5 sides, and if it is a regular pentagon, regular means all the 5 sides, they are of equal length, means this side, all 5 sides are equal, then the polygon is said to be a regular polygon. So here, if sides are equal, angle, all these angles, they should be of same measure. So how to find angle? Total sum, that is 5 minus 2, 3. So total sum is 540 degree. Now what about the angle? So here number of sides 5. So we will divide each angle. Angle measure is sum, that is 540, and number of sides 5. So angle here, that is always 108 degree. Every angle is of 108 degree. So in this way, if we have given the number of sides and a polygon is a regular polygon, we can find its interior angles by dividing the sum of all angles by number of sides. So this is an important formula, please note it. And exterior angle, if this angle is 108 degree, when now this angle is the exterior angle. If this angle is 108 degree, this angle is supposed to be 72 degree because linear pair of angle. So this is also apply for the exterior angle also, because the sum of exterior angle of any polygon is always 360 degree. Now we will discuss about the smallest polygon, that is triangle with 3 sides, and in detail we will discuss about the similarity. In lower classes we have discussed in detail the congruent figures and congruent triangles, various rules. Today we will discuss about the similarity, similar figures. Like congruent figures, we have same shape, same size. If 2 triangles are congruent, then their corresponding sides and their corresponding angles, they are always equal. Suppose we have a triangle ABC and one more triangle DEF. So here if both triangles, this is sign of congruency, congruent. When side AB is equal to DE, side BC is equal to EF, and the third side, that is AC is equal to DF. And these are 3 conditions, and 3 more conditions, that angle A is equal to angle D, angle B is equal to E, C is equal to F. So we are saying the triangles are congruent. Congruent figures, same shape, same size. For example, are bangles, ATM cards, playing cards, all cards, pack of cards. We have 52 cards, their shape and size, that is same. So these figures are your congruent figures. Similar figures in triangles, if 2 triangles, triangle ABC, if this is a triangle ABC and one triangle is DEF, ABC, and this triangle is DEF. Now shape is same but size is different. There is an enlargement. This is a smaller one with some scale factor. Here when 2 triangles are similar, then we have again 6 conditions. Angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. And 3 more conditions, the ratio of their corresponding sides, that is AB upon DE is always equal to BC upon EF is always equal to the third side AC upon DF. So we have 6 conditions. If these 6 conditions are fulfilled, corresponding angles A, B, C, D, E, F, 3 angles, and the ratio of the corresponding sides is, then we are saying these 2 triangles are always similar. So here we'll write triangle A, B, C is similar to triangle D, E, F. So dear students, we will discuss in details. We will apply the concept of the similarity to solve so many problems based on triangles. And the important rule, that is the theorem, that is basic proportionality theorem. If triangles are similar, we can apply the concept of basic proportionality theorem. Then we will discuss in detail today about the area of the triangles, and even we will discuss about the 3-dimensional figures, about the volume also, and the similarity. So basic proportionality theorem says that if any line is drawn parallel to any one side, let this is BC is any side, and any line XY is drawn parallel to this triangle side BC, then this line L divides the other 2 sides AB and AC in the same ratio. Let this point is X, this point is Y. So BPT says that AX upon XB is equal to AY upon YC. So we will discuss in detail. We will discuss in detail today about the converse of BPT and the criteria for similarity, then a little bit information about the area and the volume. If a figure is 3-dimensional shapes, so and figures are similar, so we will discuss in detail. Basic proportionality theorem, BPT. It was introduced by a Greek mathematician Thales. So this theorem is also known as Thales theorem. So in basic proportionality theorem, BPT, if we have any triangle PQR, triangle P, Q and R, so statement says if any line drawn parallel to, let here R and S is drawn parallel to QR, RS is drawn parallel to QR, it is given, then always PR upon RQ is equal to PS upon SR, or even PR upon PQ is equal to PS upon PR, or even their reciprocal, QR upon RP is equal to RS upon SP. Adding one both side, adding, it is a sign of equality here, so we can add one both side by taking reciprocal also, we can adding one both side, so we will get these results, that PR upon PQ, that is PQ is equal to PS upon PR. So this is the concept of basic proportionality theorem. Now it's converse. If the sides are in ratio, if it is given, that definitely converse says that RS is parallel to QR. So in first case, if we have any triangle, and in that triangle, if a line is drawn parallel, if this line is drawn parallel, suppose this here it is A, B, C, and this point is D, and this is E. So here always AE upon EB is always equal to AD upon DC. So here ED is parallel like here. Now if converse, if a triangle is XYZ, XYZ is a triangle, and if 2 points, let this point is L and M points, such that XL upon LX is equal to XM upon MZ. If it is given, then confirmed. If we join LM, then converse of basic proportionality theorem says that LM is always parallel to your X, that is XL upon X, it is Y, XL upon LY and XM upon MZ. So here LM is always parallel to YZ. So this is the basic proportionality theorem and its converse. Now the criteria for similarity. We have basic 3 criteria for similarity. First one, A rule. In general, 2 triangles are said to be similar when we have 3 corresponding angle equals and ratio of the corresponding sides same. But if we have only angles, all 3 angles are equal, then triangles are said to be similar triangle. Let's take a triangle. One is a small triangle and another is the bigger triangle. DEF and triangle ABC. If angle A is equal to D, B is equal to E and C is equal to F, by AA rule we will say the triangles are similar. Even if we have the 2 triangles, in 2 triangles only 2 angles are given, like the angle, any 2 angle, B is given, E is given and both are equal, C is given, F is given and equal. So even AA rule, if 2 angles are given, then we can find the third angle by angle sum property, because sum of the all 3 angles is 180 degree. So AAA rule or AA rule is one and same thing. Now next, second is if the corresponding sides are in ratio, like AB upon DE is equal to BC upon EF is equal to AC upon DF. The 3 corresponding sides are in ratio, then that is called side rule of similarity. And the last one, that is side angle side. If the sides, 2 sides and the angle between them, if AB upon DE is equal to BC upon EF and this angle B and E, important condition is the angle must be between the sides. We are talking about AB and BC. So here it is DE and EF. So here, dear students, this angle should be in between these 2 sides. This criteria is called as side angle side rule of similarity. Now in last, we have the relation with the areas. If 2 triangles are similar, triangle ABC is similar to triangle DEF, then what is the relation of their areas, the ratio of their areas? So very important relation here. If area of a triangle ABC upon area of a triangle DEF, the ratio of the area of these 2 triangles is always equal to the ratio of their sides, that is AB upon DE whole square, which is further equal to, BPT says that it is equal to BC upon EF whole square is equal to AC upon DF whole square. So here, if 2 triangles are similar, the ratio of their area is always equal to, if A and B are the ratio of their corresponding sides, square is very important. So here, this is the important concept about the area of the triangles. Now if we have a three-dimensional figure, like cubes are there, cuboids are there, and both the figures or both the things, they are of shape, similar, then what about their volume? In volume, the ratio of volume 1 upon volume 2 is always equal to A upon B whole cube. So dear students, this is very important in examinations regarding the area and the volume. So we should remember these things, BPT and criteria of similarity, and these relation of area and the volume of the similar figures and your objects also. So at the end, let's recapitulate. We have discussed about polygons. Poly means many, guns means side. To find the interior angles of sum of the polygon, the formula is n minus 2 into 180. Regular polygon means when the sides, all sides are equal and all angles are of same measure. Exterior angle sum of all polygon is always 360 degree. So dear students, you can go through the sums of these polygons on these concepts, and in next class we will go for the further these applications of these properties of geometry. Thank you very much.